Okay, let's see. Testing, testing. Okay, hello. Test, test, test. Testing, testing, testing. All right. Mm-hmm. Okay. Mm-hmm. Wait, no, didn't mean to open Photoshop. Now I have to close the Photoshop. Oh, hello, welcome to the stream, Hero End. Oh, you left? Okay. Here we go. Now I'm doing some OpenGL programming with C++. We're learning how to do graphics programming in OpenGL, and the programming language we'll be using is C++. I've already got, before we get started, you should know that I've already got the necessary libraries installed, and so I will not be going over those in this video, but I will, if you need help getting the proper libraries installed, I'll make another video later for that. But you should just know that there are libraries necessary to get OpenGL working, if you're going to be coding in OpenGL. If you're just displaying graphics that were made in OpenGL, I think pretty much every operating system these days, I think, should have the ability to display OpenGL graphics already installed by default. I think it comes with like every operating system. Windows and Mac for sure, and I'm pretty sure most Linux distributions also come with OpenGL pre-installed, at least for viewing OpenGL graphics. However, if you want to actually create OpenGL graphics, you are going to need to install some libraries, and I've already done that on my computer, so I'm not going to be going over it, but like I said, I'll do another video later if people need pointers on how to actually get the OpenGL libraries set up. I'll make another video for that later. Anyway, I'm gonna just jump right in here. So I've got my project all set up. Just got our main file, main.cpp. If you notice, if we press the play button or the debugger button, whatever, I've already got it set up to display this nice little window. So this is already set up. And let's see the code for that. Right here, this is the code for displaying the window. It all fits right there on one screen. It's all the code right there. That's all you need for displaying the window. But yeah, this GLFW is the library I'm talking about. That the GLFW3 library specifically is what you will need to install in order to do graphics programming in OpenGL. That library does not come pre-installed on most operating systems, as far as I know, so you will need to install that. Once you've got it installed and got this window right here set up, and so that it displays the window when you launch your project, you should be good. But yeah, I'll make another video later that shows how to get to that point. So yeah, let's get started. For this video, I'm going through the OpenGL programming guide, the 9th edition, the official guide to learning OpenGL version 4.5 with SPIR V5, I guess. Is Spire. And it's the authors are John Kisinich, Graham Sellers, and Dave Schreiner. It's from the Kronos OpenGL ARB working group. It's got a red cover. It's called most people call it the Red Book for graphics programming. It's a pretty thick textbook. I can't show it to you obviously because I'm doing a VTuber model in this video rather than a webcam. But you know what? That's okay. If you Google the graphics, the OpenGL programming guide, Red Book, you should be able to find it. I'll also put a link in the description. Anyway, so yeah, we got our triangles. We've got two files here. We've got main.cpp, which is responsible for rendering the window. And then we're going to be doing the actual graphics rendering for rendering the triangles. That's going to be here in the triangles.cpp file. And CPP stands for C++. That's how you know it's a C++ file. It ends in the CPP extension. All right, so first we're going to do, I'm basically going to be copying the code here from page 5 in the textbook, chapter 1, Introduction to OpenGL. Oh, hello, welcome to the stream, Bloody Val Undead pre-debut. I see this is your first time here. Welcome to the stream. I am Mephistus, your friendly neighborhood cyberpunk hacker trans girl, here to hack the system and infiltrate the network. Watch out for my evil twin, and welcome to the Agora network. Hi, yes, I am streaming programming on Twitch, YouTube, and Irium simultaneously right now. So yeah, if you want to follow along with what I'm doing, you can watch my channel on either Twitch or YouTube, or you can just stay there on Irium and just listen in. But yeah, anyway, so first I got to include the IO stream. So pound include pripty. Yes, I see you are pre-debut. We're gonna. When do you have a debut date yet or no? But anyway, so I got to do include IO stream, just like that. And let's see the next. Oh, I see you're calling my model pretty. Oh, thank you. Yes, I designed this character model myself. I did not draw it. I went through the Irium debut support program, and they drew the character model for me, but it was according to my specifications. This character model is loosely based on the female V from Cyberpunk 2077, but different enough to be legally distinct. So yeah. Anyway, where was I going? Oh yeah, and then I also need to do using namespace std. Stands for the standard namespace library. And yeah, when I went through the Irium debut support program, the staff at Irium, they went and found a Japanese manga artist, or mangaka as they're called, to draw my character for me. I hear that's actually pretty expensive, and so I kind of had to sign a contract with Irium that I would stream for at least 300 hours on their platform, and I get this free character model in exchange for streaming for 300 hours, at least. I think I'm gonna stay on Irium even after I get those 300 hours in, just because I like the platform. I met some good friends there. So I don't know, something about Irium makes it easier to get into streaming than like Twitch or YouTube. All right. Yeah, not yet, but I've been doing very well with my pre-debut stuff when it comes to socializing with the community. Oh, nice. Yeah, Irium's got a great community. It's very easy to connect with other streamers. So yeah, that's the thing I really like about Irium. It's easy to start building a community right away because you can get viewers like instantly. Whereas with YouTube and Twitch, it takes like a long time of streaming into the void before you even get any viewers. But with Irium, you get viewers right off the bat. It's pretty cool. I mean, it's not a lot of viewers. It's like probably just one or two or three, like maybe half a dozen viewers starting off. But like 6 viewers to start off with is way better than streaming into the void on YouTube and Twitch. So that's why I like Irium. I get a community instantly right away as soon as I start. Anyway, let's see. Next one we got to do. I hate just waiting, so I'm making the most of my pre-debut time. Oh, cool. Yeah, let me know when you got a debut date. I'll try to make it if it doesn't overlap with my work or school schedule, or my own streaming schedule, or the streaming schedule of another streamer I watch. I'll try to make it. Okay, let's see. Next we got to do. Okay, pound include a VGL dot H. Okay, gotta include the VGL header. You found some good streamers you like? Who's your favorite streamer so far? Okay, pound include load shaders.h. Load shaders.h. Okay. Cannot open source file load shaders.h. I don't know. I'll fix that later. I'm not sure what the deal is there, but I thought I had everything working or installed. Maybe not. Yeah, because I installed the GLFW library and I thought that would be enough. But apparently there's this other thing I need. I'll figure that out in a bit though. Okay, now we do enum VAO IDs. And autocomplete is filling it in for us. So we got triangles and num VOAs, or VAOs. Okay, so as our 2 inputs for that variable, for our enumerator. And then we got to do another enumerator. It's enum buffer IDs. Autocomplete is filling it out for us. You just press tab and autocomplete does it. And one of my programming teachers has said he kind of hates autocomplete for that reason, because if you like just press tab to autocomplete the line, you're not really learning how to do it, even if it's right. And AI just makes it even worse. But I think he's got a point. I should turn off autocomplete one of these days. I don't know. I'll do it later. Okay, so we got the buffer IDs enumerator, and the variables in that are the buffer, the array buffer, and the num buffers, which is number of buffers. Okay. Then we need another enumerator, and this one is going to be attrib, and the autocomplete just filled it in. So yes, attribute IDs, or attrib for short. And the V position is going to be 0, apparently. I guess I'm assuming that V position stands for vertical position. Okay, now let's see, GL uint. GL uint. I think, no, not. Okay. Autocorrect tried to change my variable type there to something else, and it was wrong. And this is going to be called VAOs. No, and just nothing after that, just an array of type GLUint. I think that means it's a type of integer that's unique to the to the OpenGL library. Okay, and then num VAOs. So we've got our array here. We've got an array of integers. They're special OpenGL integers. So we got a, and then okay, no, not GM time. Okay, the autocorrect kept trying to change my code and it changed it wrong. Okay, buffers. No, we need square brackets here, not the curly brackets. Num buffers. Okay. GLU int, VOAs and number of VOAs, and the number of buffers. All right. Now we have a constant, a constant integer, const GLU int num vertices 6. Oh wow, autocomplete filled it in automatically again. I'll be posting it on my Twitter. Follow on Twitter to stay up to date. Okay, I'll make sure to check out your Twitter. Let me see, what's your Twitter? Here, I'm going to follow you on Twitter real quick. Hold on just a second. Okay, hold on. All right, let's see. I accidentally closed out of Virium. Let's go back into that. Okay, sorry about that. I tried to go to your Twitter and then it closed out of Virium and I realized it would kind of pause the stream. So I'm actually just going to come in here with my alt account and then I'll into Irium. Then I'll go to Twitter through my alt account rather than that account. That way the stream won't close for you. Okay, let's see. Bloody Val Undead. Okay, I'm opening up your Twitter profile. Oh, hey, someone else just joined the stream. Who's that? Robin. Welcome to the stream, Robin. Hello, I'm Myth. I write poems. I'm a freelance photographer, writer, and lyricist. Okay. All right, let's see. Okay, I followed you on Twitter, Bloody Val Undead, and let me know when your debut day is, and I will try to be there. Okay, there we go. You have Discord, right? Do you have a Discord server set up yet? Yeah, if not, you should probably get a Discord server set up. If not, maybe it might not necessarily be. You might not need to have one like right away, but it would be better to have one as soon as possible. I would recommend having one like right at the start of on your debut day. So at the start of your first stream, you can tell people to join your Discord server. That would, I think, be a good idea. Helps start building your community from day one, you know? Anyway, on to the next line of code. Let's see. Where were we? Okay, yeah, that's the code for page 5. There we go. Gotta go page...
It looks like your Wi-Fi name or password has changed. To update your Wi-Fi information, go to the Alexa app.
Be quiet, Alexa.
It looks like your Wi-Fi name or password has changed. To update your Wi-Fi information, go to the Alexa app.
Alexa, be quiet. Yeah, I need to change the, update the Wi-Fi password for Alexa. Okay, where were we?
It looks like your Wi-Fi name or password has changed. To update your Wi-Fi information, go to the Alexa app.
I know that, Alexa. I'll do it later. Be quiet. All right, where were we? Init. And autocomplete just gave us a full sentence. Initialize the data for the triangles. What? Okay, this is too much autocomplete. This is like AI-powered autocomplete. Yeah, I don't. Okay, I need to turn. I want to turn off my autocomplete. I don't. No autocomplete. I don't want autocomplete. I don't want the AI doing it for me. Okay, so we got init void. Oh wait, void init void. That's right. Okay. Okay, the autocomplete did catch a little typo there. They've got it printed weird in the book here. They have the variable, the return type on one line, and then the variable name on, or the function name on the next line. I'm not sure why they printed it that way, but that's why I missed the return type as I was typing it in. All right, okay, so then the next static const. So we got a static and constant and autocomplete. That's too much autocomplete. I don't want. Hold on, how do I turn this off? I'm going to turn off my autocomplete. Let's see, turning. Let's see. Off autocomplete AI Visual Studio 2026. Disable AI in Visual Studio. So let's see. All right, here we go. So open settings. Hold on. Where's the settings? Tools, options. Okay. Okay, so we go to tools and then options. There we go. Tools, options. Locate AI assistance. Expand environment. Preview features or AI assistance. Where we got that? Come on. Oh, welcome to the stream, GI. Oh, did they leave? Looks like they left. They joined and left. I should have greeted them. Oh well. All right, where were we? Okay. You having a good time at least, Robin? Or are you just hanging out? You just lurking for points? Or are you actually interested in programming for at all? That's okay. You can lurk for points. That's fine. Okay. I'm not seeing either preview or preview features. Maybe it's just called Copilot. Maybe that's it. Okay, that seems to have done it. No, still doing it. Okay. Okay. Excuse me. It says, look for options such as enable GitHub Copilot, enabled AI-powered code completions, enabled profiler Copilot agent, enabled debugger AI suggestions. Debugger. Where's the debugger? Okay, maybe it's in extensions because I'm not seeing anything in an environment. Oh, hello, Akira. Welcome to the stream. How you doing? Imagination becomes reality coming through your screen. Wow. Wow, you have pre-debut, I see. Welcome to the stream. Hi, I'm okay. How are you? I'm doing okay. Let's see. Yuki. I'm doing some computer programming right now. I'm currently dual streaming on YouTube and Twitch. I guess I'm actually triple streaming on YouTube, Twitch, and Irium. But you can't see the code on Irium because Irium is there's no screen sharing on Irium. So if you want to see the computer code, you'll have to go to either YouTube or Twitch. But if you just want to sit here and yap with me as I try to debug, as I go through this coding stuff, yeah, I'm learning. Oh, I'm learning how to do graphics programming in C++ and OpenGL. Yeah, I don't know. You probably don't. Yeah, it says in your profile settings that you're a VGen artist. So my guess is you probably don't know anything about computer programming. Is that correct? I mean, I guess you could be an artist and a programmer, but my guess is probably not. But yeah, I'm just learning how to program graphics, and right now I'm doing what's called the Hello Triangle um, program, which is basically where we do the bare minimum level of programming necessary to get a triangle to render in the window. But yeah, let's see. And I'm trying to right now. I'm trying to figure out how to disable the AI Copilot thing in Visual Studio. Yeah, I don't really know anything about coding. Yeah, I figured. It was just a guess, but yeah. Anyway, I'm trying to disable the AI assistant in Visual Studio because it's being kind of annoying. It keeps trying to finish my code for me. And I'm like, no, I don't want to have the AI finish my code for me because then I won't learn. You know, so it's supposed to be a learning thing. Oh, here we go, right here. Enable Copilot completions, enable next edit suggestions. We are going to disable both of these. I just had to click on this little GitHub Copilot icon. It finishes the code for you. Yeah, I know, right? They've got AI these days that'll write the code for you. But I'm like, on the one hand, it can be nice if you just need like generic boilerplate code that you've written 1,000 times and you just want the AI to just create the boilerplate code for you. But it can be kind of annoying if you're trying to learn how to program and the AI keeps suggesting how to complete the code. Because if you just use the AI to complete the code, then you're not really learning. So took me a little bit to figure out how to turn that off, but I think I got it now. It's turned off. Okay, yes, autocomplete is now turned off. Okay, good. Yes, oh, that's good, yes. Yeah, I worry about the future of programmers with AI these days. Because unlike artists who have kind of rejected AI, I've noticed that programmers, by and large, have very much embraced AI. So there is that kind of a distinction there, or at least it seems. I mean, there is a bit of a divide in the programmer community over AI, but it's not as big as the divide in the art community. So, like programmers seem to be much more willing to accept AI than artists do for some reason. Yeah. But I do worry because if the AI is writing your code for you, a lot of these younger programmers are not going to learn how to do it the right way, and they won't learn how to program because the AI will just write all their code for them, and then they won't learn it themselves. It's like worse than the autocomplete. Like auto finish my code for me. No. How will I learn? Okay, anyway, we got static const GL float vertices, and then number of vertices. Anyway, so yeah, I'm kind of talking about the code. I'm like verbalizing each line as I type it in. So yeah, let's see, static const GL float vertices num vertices 2. Okay. So we've got a two-dimensional array of vertices here, and it is both static and constant. Yeah, and let's see. And we need an equal sign there. I'm going like that. I like it like that. Takes up less room that way. And let's see, so then we got, okay, so we've got two triangles, vertices for two triangles here. And it's got, looks like we need to have, okay, so a vertice, so the vertice is the, like the corner of the triangle or the point. So a vertice is a point in space. And it looks like right here we've got, because we're going to be doing, I guess, two-dimensional rendering. So we're going to do each vertice looks like it has an x coordinate and a y coordinate. They could also have z coordinates, but it looks, this tutorial I'm going through right now only is giving me x and y coordinates. And it's, so this first one is negative 0.90 for the x value, and then negative 0.90 for the y value as well. And then we can just duplicate that by pressing Control D. And that, and we need, looks like we need a total of 6 of them, 6 vertices, one for each of the different triangles. And so we go. These first 3 vertices are going to be triangle 1, and then these other 3 vertices down here are going to be triangle 2. And anyway, right, because I copied the same vertice for all 6 of them, I just hit Control D, and that so I've got the same coordinates for all 6 vertices, and that's not what we want. That's just to get we can change these here. So I got to change this one from negative 0.90 to positive 0.85. And that'll move that vertice up to a particular point. And then do the same thing on this one over on this here. So we've got, on the y coordinate, we change that one to 0.85 instead of negative 0.90. So that, and that helps us on that. And that moves that vertice up to a different location. Okay, now that's for triangle 2, we're going to change the positive and negative. You know, I'm actually going to duplicate the code there again. That way I don't have to rewrite it. So, because it looks like they are, well, I guess I'm still going to need to rewrite some parts. Well, I guess I couldn't. It doesn't matter. Oh, well. Okay, so we change this from positive to negative. And this one's going to be, so this one's positive 0.90 on the x value, and then this one's going to be negative 0.85 on the y value. And this one, oh, we wanted, I guess copying it was the wrong thing to do because now I'm having to change it back. Okay, so on that one we wanted positive 0.90. This one also wants, the tutorial says, to make that one's positive 0.90 as well. And this one should be changed back to 0.90. Yeah, okay, copying and paste was the wrong option there. Oh well. Okay, and then we got, this one's going to be negative negative 0.85. So that should be the 3 vertices. So 3 vertices per triangle. Each vertice is a corner, and a triangle has 3 corners. And a single corner has 2 coordinates, an x value and a y value, which determines where that point in space falls on the screen. And then we draw lines between each of the points, and that'll give us our triangles. sort of like dot to dot, connect the dots kind of thing. But there's, let's see, next we got to okay, we've got our vertices set up. Next we're going to do GL, so GL create buffers. Okay, yeah, just GL create buffers. And then parentheses, not 90, parentheses. And the variables it takes as input are num buffers and buffers. So it takes in the variables that this this function takes in. So we're doing the function create buffers, and it takes in two variables: the number of buffers and then the buffers themselves. It's giving me an error code right here, like error. It says error identifier GL create buffers is undefined. I'm just typing in exactly the code from the book right now, so we'll figure out. I'm assuming we're going to figure that out later, or I can do something else. I don't know. I'm just going to copy the code from the book for now and not worry about the errors. Okay, let's see. And then next we got GL name name buffer storage. Okay, and then this one takes 4 parameters. Okay, so it takes an array of buffers. So our buffers, we're going to put that in array buffer, not bugger. I keep misspelling buffer as bugger. And then size of, and the size of function, we're going to put vertices in there. Vertices, there we go. So we're getting the size of our vertices array. Because let's see, here's our vertices array right here, and you can tell it's a two-dimensional array because it's got two sets of square brackets right here, with one with the number of vertices variable plugged in, and the other one with just the number 2 plugged in. So that'll give us a two-dimensional array. I guess that's for the number of triangles, because number of triangles is going to be 2, and then each triangle is going to have a certain number of vertices. Looks like the number of vertices is going to be 6. So 6 vertices per triangle with 2 triangles. That's what that means. At least I think that's what that means. I'm still new to this. Okay, and then we put the vertices array itself as input. If I can spell it right. There we go. All right, and then let's see, vertices, and then just 0. Those are the 4 parameters that function takes in, or is going to take it, or that it's going to take in once we define it. Right now the function is undefined. Now we're going to be creating another array for shaders. And it's going to be called shader info. No, not shader. Autocorrect tried to change it to shader pointer, which is not the AI powered autocorrect, just regular autocorrect. Like the kind of autocorrect that was there before AI existed. So, and then we got an equal sign and then the curly brackets, and then I like to fill out or rather do the whole sentence or the whole line up until the semicolon, until the end of the line, and then I go back and fill in the input. Don't have to do it that way, but I like to do it that way. So then we do this. Okay, shaders. Okay, no, we've got. Okay, yeah, so we've got our shaders array. It's a one-dimensional array because it only has one set of square brackets. And the tutorial in the book doesn't have anything in there, so I won't put anything in there either. It looks like we have 3 parameters in here. Just like that. And the first one is going to be, it's all capitalized because I don't know why. That's just the way it's printed in the book. So we got GL texture shader. And that's going to become, that also needs to take in triangles dot vert. Then we have another one. GL fragment. Oh, Akira left the stream on Irium. Now I am streaming into the void. It's okay though, I will continue talking even though there's nobody watching right now because this is going to be recorded on YouTube and it's going to go up as a VOD later. And even if there's no people watching the stream, there might be people watching the VOD in the future. Hello, future peoples. All right, where were we? GL fragment. Shader, GL fragment shader. And that's gonna, we need to do triangles.frag on that one. Don't have to put a space after it. Like I could have it like this. The compiler won't care. But I find it looks a little nicer if I put it like that, and it's easier to read that way. A lot of people do it that way. It just makes it easier to read. It's like up here too in the vertices for the triangles. We don't need the spaces after and before the coordinates. We could do it this way without those spaces. Again, it'll compile just fine. The compiler doesn't care about those spaces. But it does make it easier to read if just a little bit if we have those spaces in there. Just makes it a little bit more visually or aesthetically pleasing. You know. Okay, next we got GL none null. And I don't know why we have to take in a null parameter. I'm just following the tutorial, what it's got written in the book, but I am going to trust that it will make sense later. GL uint. No, okay, we got another. No, not GM time. GL uint. GL uint program equals load shaders, and then then we take in a parameter of shaders. Then we got GL use program, and then take in the parameter program. All right, we got a few more lines here. We got then we got vertex arrays. GL gen vertex arrays. And that takes in two parameters. Takes in num. We're gonna feed it num VAOs as our first parameter, and the second parameter is going to be VAOs. I can type. There we go. Next, GL bind a vertex array. That's going to take in VAOs. And that's going to be an array, and we're going to put triangles as the variable for the number of items in the array. And we got GL bind buffer. GL bind buffer. We got GL array buffer, and then buffers and array buffers. Wait, no. Buffer, singular, not plural. See, it was giving us an error there until I changed it from plural to singular. Because you got to get the name exactly right, otherwise the compiler won't find it. Okay, where were we next? Okay, that's all for the bind buffer. Next, we got to do GL vertex attribute pointer. That is GL vertex attrib. We're not spelling out the whole word. It's just going to be shortened to attrib instead of attribute. But you should know it stands for attribute. Attrib pointer. GL, so graphics library vertex attribute pointer. Or GL vertex attribute pointer for short. Okay, V. Okay, what was it? V position. And 2 GL float GL underscore false. And then 0. And then buffer offset. And that takes in, we're going to feed that 0. So that's 1, 2, 3, 4, 5, 6 parameters that function takes in. Let's see. Then next we do, now we've got GL enable vertex attribute array. So graphics library or GL enable vertex attrib array V position. All right, I guess that's all we got for initialization. And we're gonna do this and do big like line like that, just to separate out the initialization from other things. You find that it's common for programmers to do that kind of thing when they create a new function, just because it makes it easier to spot where a new function starts in the code. Just a little visual separator. And then, so that's all we need for our initialization function. Next, we're going to do our display function. And display. Void display. And that, so void, the display function does not take in any parameters and it does not return anything. So it's got void as its return type and void as its as the parameters that it takes in, which means it takes nothing and returns nothing. It is void or no returns and no input and no output. It'll perform functions within itself, but it doesn't need to take in anything or output anything. Okay, so next we've got static const float black. Okay, we're doing colors now. Static const float black, and it's going to be an array, a one-dimensional array. And we're going to have 4 parameters in that for the color, it looks like. So yeah, we're doing an array of, we're going to be declaring our colors by using a static constant float one-dimensional array. And it's got four parameters. It looks like it's going to be, I guess the parameters are going to be the red, green, and blue, and alpha. So 0.0f, and I can just copy this because it's all zeros. Last one doesn't need the comma there because the comma is only on the ones that aren't that have another one after them or another parameter after it. So yeah, if you're doing a list of parameters, you will need a comma on each parameter in the list except for the last one. Which I think is kind of how lists work in English. When you're writing a list of stuff, you can only put commas between each items in the list, except for the last one. So GL, next we got GL clear buffer FV. Yeah. There we go. GL clear buffer FV is going to take in 3 parameters. First is GL color, then the number 0, and then the black array we just created above on the line just above that. And a lot of these, the compiler is looking like it's not it's giving me errors on pretty much every single line, but I'm just copying the code exactly like it appears in the book, so I'll figure out how to deal with those errors after I get the code completed. Okay, next we got GL bind vertex array. And this is going to take in the VAOs, VAO array, VAOs, and the parameter that takes in is triangles. I'm going to feed that the triangles variable as its parameter. Let's see. Oh, where did I put my iPad? Oh, there it is. Go on, test my iPad. sure the stream is going on my iPad. Use my iPad to test the stream, I should say. What? Okay, yep. Okay, yes, it is working. All right, let's see where we're going. I think I will be watching Sinnoh's stream on my iPad while I'm doing this.
Dark and I was alone and I was gone and there was nobody there and nobody loved me.
Gonna watch a stream while I'm streaming.
I can't stop pissing. I just can't stop pissing. And that's why nobody loves me. I look at my mom every morning when I wake up and I fucking start pissing and that's why nobody likes me because I'm full of piss. Oh God. Oh, that's why nobody loves me. Everybody hates me, wants to ban me because I piss every time I walk into the room. Oh God. Anyway.
Okay, that's Sinnoh's stream. I shouldn't be.
They're getting paid $5 to beta test Domino's new app. So is she. And then literally all of you now get paid just for ordering pizza. Get $5 to use on next week's order when you beta test the new app from Dom.
$5 to beta test Domino's new pizza app?
Only went out for a quick jog.
I might try that. $5? I mean, it's $5.
Chapter 19. And a story this good. Chapter 30. Isolde. Chapter 38. Maybe one more chapter. Chapter 40.
All right. We're in enough ads. Yeah, I should not, I guess I can watch other people's streams, but I shouldn't have the audio going in the background because then that's their content, you know? I gotta collect my points for other streamers. Show my support. We'll just put that there. All right, where were we? Okay, we did the GL bind vertex array VAOs triangles. Okay, so that's all the code on page 6. So now to page 7. Looks like page 7, we're still in the display function. Okay, we got one more line of the display function on page 7. And that is GL draw arrays. Takes in 3 parameters, GL triangles, and then 0, GL draw arrays, 0, num vertices. Okay, and that is everything for the display function. Now we got to do, next we're going to do our main function, or let's see. I think I've separated the triangles code out from our main function over here, but I think it might be essentially the same as this window right here. But no matter, we'll do it anyway. We'll redo it main. So our main function is going to be int main. In C++, the main function needs to alwaase return an integer, because otherwise it won't compile properly. When I first learned to program, my first language was C#, and in C#, the main function is usually void, because it doesn't return anything, which honestly makes more sense. But C++, you have to return an integer, because the compiler uses that to determine whether or not the whether or not the program crashed or not. C#, you don't need to worry about that. It's just okay. Int argc, and then char, which is short for character. We got a character pointer here. Argv. So yeah, so okay, so this is the input. If someone's like, when they launch the program, if there's input on the command line, then that input will be sent to the main function. And this first one here, this first variable, argc, this is the number of parameters that are sent in by the user. And then this one, the character pointer, this will create an array of all of the functions or commands that the user sends to the program when it starts up. Anyway, now we go GL FW init. Then GL FW init. Oops, I did GK, not GL. Typo there. Okay, GL FW init. And then next, GL FW capitalized. GL FW window pointer. Window equals GL FW create window. GL FW create window. 640, 480, triangles, null, null. Okay, so that's 1, 2, 3, 4, 5 parameters on that function. And it looks like the autocorrect changed the name of my function, and I didn't notice because I was looking down at the book. No, it's just called window. Okay, so GLFW window pointer, and we have a variable called window, which autocorrect was trying to change to something else. Okay, next we got GLFW make context current window. GL3 init. That's graphics library 3 window init. And then just straight up init initialization. That'll call the initialization function. And then we'll do a while loop here. And inside the while loop, it's going to trigger if not the exclamation mark or the bang mark means not in C++. So not GL FW window should close. And we'll pass it the window that we created above. So see this window variable we created right here, and we named it window just because that's a super easy name, and we're passing that as the as the window into this window should close function. And we're saying not window should close, which means the window should not close. So as long as the window should not close, we're going to do stuff. And while the window should not close, we're going to display or call our display function, which is this function right here. This is our display function. So that's going to get called every frame as long as the window should not close. Then we're going to call our GL FW swap buffers. Swap buffers. And we're going to pass the window variable into that, or the window object, I should say. GL FW, because yeah, C++, we're doing object-oriented programming here. So GL FW poll events. And that doesn't, we're not passing anything into that function. It just runs on its own, no input. And so yeah, that's done, looks like. And then we got to destroy our stuff once everything's finished. So GL FW destroy window, not windows. And then we destroy the window. Yeah, this is like basic memory management. Because C++, you got to manage your memory manually. And next we got GL FW terminate. And that just frees up the memory so we don't get any bugs. Alrighty. And we got 42 errors that are going to prevent this from even compiling. All right. Yeah, let's see in the textbook. Where does it say? All right, well, that may be more code than you were expecting. You'll find that this program will be the basis of just about every OpenGL application you write. We use some additional software libraries that aren't officially part of OpenGL to simplify things like creating a window or receiving mouse or keyboard input. Those things that OpenGL doesn't include. We've also created some helper functions and small C++ classes to simplify our examples. While OpenGL is a C language library, all of our examples are in C++, but very simple C++. In fact, most of the C++ we use is to implement the mathematical constructs, vectors, and matrices. In a nutshell, here's what example 1.1 does. We'll explain all of these concepts in complete detail later, so don't worry. In the preamble of the program, we'll include the appropriate header files and declare global variables and other useful constructs. So this part right here would be the preamble to the program. That's what they're talking about. Yes, in general, we eschew global variables in large applications, but for the purposes of demonstrations, we should use them here. Just got a note there. Trying to find where is that note mentioned. Oh, well, I won't worry about it. Well, hello, welcome to the stream. Onure, what am I trying to create? Oh, it's just a hello triangle program for the for graphics programming in OpenGL. So just the very basic, just getting some triangles to render on the screen. So yeah, welcome to the stream for the first time. How you doing? Let's see. Yeah, you're the only wholly very basic. I have no idea what that. Okay, yeah, I'm just it's like the very fundamentals of graphics programming. But thank you. I'm trying. I'm doing great, and you doing pretty good. Just going over this code right here. I'm reading. I'm actually copying code from a textbook right now. So this is not original code. It's code I'm copying from a textbook, and I'm reading along with the textbook as I learn, and maybe you can learn along with me. Anyway, let's see, where was I? Okay, so we've got our init routine right here. So yes, right here, this is the init or initialization routine. And in the textbook, it says the init routine is used to set up data for use later in the program. This may be vertex information for later use when rendering primitives or image data for use in a technique called texture mapping, which we describe in Chapter 6. In this version of init, we specify the position information for the two triangles that we render. After that, we specify shaders we're going to use in our program. In this case, we only use the required vertex and fragment shaders. The load shaders routine is one that we've written to simplify the process of preparing shaders for a GPU. In Chapter 2, we'll discuss everything it does. The final part of init is doing what we like to call shader plumbing, where you associate the data in your application with variables in shader programs. This is also described in detail in Chapter 2. All right, and I'm realizing now I kind of skipped the first part of this chapter just because I wanted to get right into the code. But you know what? That's okay. What's that? Okay. Okay. Okay, now that's the initialization function. Then we got our display, the display routine here. Okay, and the display routine is what really does the rendering. That is, it calls the OpenGL functions that request something be rendered. Almost all display routines will do the same 3 steps as in our simple example here. And finally, yeah, so you've got 3 steps here. So we've got clearing the buffer, binding the vertex arrays, and then drawing the arrays. So these are the 3 steps right there. And then this line right here just creates a one-dimensional array for the color black. Now we got our main routine here. Finally, the main routine does the heavy lifting of creating a window, calling init, and finally entering into the event loop. Here you also see functions that begin with GL, which is short for graphics library, but look different than other functions in the application. Those which we'll describe momentarily are from the libraries we use to make it simple to write OpenGL programs across different operating systems. Hold on. Those which we'll describe momentarily are from the libraries we use to make it simple to write OpenGL programs across the different operating and Windows systems. GLFW and GL3W. So yeah, those are the graphics libraries that you need to install in order to get render these, or get these, in order to use these functions. Because I don't know how much you know about programming, but a lot of there's a lot of stuff that you can't do by default, and you need to install certain libraries in order to gain access to particular functions. All right, and where was I? All right. Before we dive into describe the routines in detail, let us explain OpenGL labels, functions. Let us explain OpenGL labels, functions, constants, and other useful programming constructs. I only know Python and start C++ recently. Okay, cool. Yeah, I'm learning Python myself. I've actually been studying C++ longer than I've been studying Python. I've kind of made the mistake of trying to learn too many programming languages at once before I mastered one. which is not really what you're supposed to do. Generally, the advice is master one programming language first and then learn other programming languages after that. I did not do that. I tried to learn the basics of several programming languages before mastering any of them, which is not a good thing to do, but you know, that's what I did. Oh well. All right. Simone. Okay, now where are we going? Okay, what's next? Okay, OpenGL syntax. As you likely picked up on, all the functions in the OpenGL library begin with the letters GL, immediately followed by one or more capitalized words to name the function. GL bind vertex array, for example. All functions in OpenGL are like that. In the program, you also saw the functions that began with glfw, which are from the glfw, which is a library that abstracts window management and other system tasks. Similarly, you see a single function gl3w init. Yeah, where is that? Oh yeah, right here. gl3, wait, no, not that one. Or wait, is that how it's supposed to be? Did I make a typo? I did make a typo. This is supposed to be gl3w init. Forgot the W right there. So yeah, gl3w init. gl3w init, which comes from gl3w. We describe the glfw library in more detail in Appendix A. Oh, there's my cat Bandito. I don't know if you could hear his meow. What? Yeah? Yeah, you want attention? Yeah? Yeah. Meow. Okay. I guess it's some scritches. Oh, the wet food's all gone. He probably wants more wet food. Oh, he's trying to get it out of the corners. All right, where were we? All right. Similar to OpenGL's function naming convention, constants like GL_color, which you saw in display, yeah, right here, GL_color, that one right there. I think I'm let you hear. I completely lost. Have a great day. Okay, see you later, Onir. Thank you. Okay, similar to OpenGL's function naming convention, constants like GL_color, which you saw in display, are defined for the OpenGL library. All constant tokens begin with GL_ and use underscores to separate words. Their definitions are merely pound defines or the hashtag defines found in OpenGL header files, glcore arb.h and glext.h. To aid in moving OpenGL applications between operating systems, OpenGL also defines various types of data for its functions, such as glfloat, which is the floating point value type we use to declare vertices in example 1.1. OpenGL defines type defs for all the data types accepted by its functions, which are listed in table 1.1, which obviously you can't see on the stream. And let's see. Additionally, because OpenGL is a C language library, it doesn't have function overloading to deal with the different types of data. It uses a function naming convention to organize the multitude of functions that result from that situation. For example, we'll encounter a function named GLUniform in Chapter 2, Shader Fundamentals, which comes in numerous forms such as GL uniform 2F and GL uniform 3FV. The suffixes at the end of the core part of the function name provide information about the arguments passed to the function. For example, the 2 in GL uniform 2F represents that 2 data values will be passed into the function. There are other parameters as well, but they are the same across all 24 versions of the GL uniform function. In this book, we'll use the GL uniform to represent the collection of all GL uniform functions. Also note the F following the 2. This indicates that those 2 parameters are of type GL float. Finally, some versions of the function's name end with a V, which is short for vector, meaning that the one-dimensional array of GL floats instead of meaning that the, okay, so I skipped a line there. Some versions of the function's name end with V, which is short for vector, meaning that the 2 floating point values, in this case, in the case of GL uniform 2FV, are passed as a one-dimensional array of GL floats instead of 2 separate parameters. Okay, I see. So it's going to be a single parameter with a 2-dimensional array, and that 2-dimensional array contains 2 other variables. So we're going to combine those 2 variables into another function, or into another variable, or another data type. What? Oh, you're out of wet food? Are you out of wet food? You're out of wet food? Yeah, he's out of wet food. Now he's only got the dry stuff. Yeah. Okay. Okay, where was I? Okay, to decode all of those combinations, the letters used as suffixes are described in Table 1.1 along with their types. Okay, so you can't see the table here. I guess I could show it on camera, but I don't feel like turning on the camera right now. So you're just gonna have to deal with it. All right, so suffixes, we've got B, S, I, F, D, UB, US, and UI. I'll say, so the B suffix is a 8-bit integer of the signed and a C language type. Okay, so it's got a data type and a C language type and an OpenGL type. Okay, so the B suffix, the data type, is an 8-bit integer, and in the C language type, it's a signed character or signed char, and in the OpenGL type, it's a GL byte that's spelled BYTE. Then the next suffix, S, as in Sierra, is the 16-bit integer data type, and the C language type is a signed short, and the OpenGL type is a GL short. The next suffix, I, as in India, and that's a 32-bit integer. C language type is int. OpenGL type is GLint or GL size I. Then we've got F as in Foxtrot, which is the data type for that is a 32-bit floating point. C language type is a float, and OpenGL type is a GL float or GL clamp F. Then the next suffix is D, as in Delta, which is a 64-bit floating point data type. Or we have the C language type. In a C language type, it's a double. And the OpenGL type, it's a GL double or a GL clamp D. Then we have the next suffix is UB, that's Uniform Bravo, which is an 8-bit unsigned integer data type, or a C language type of unsigned char or unsigned character. And the OpenGL type is GL U byte. The next suffix is US, that's Uniform Sierra, which is a 16-bit unsigned integer data type. And the C language type is unsigned short. And the OpenGL type is GLU short. And the next suffix is UI, that's a Uniform India. And the data type is 32-bit unsigned integer data type. The C language type is an unsigned int. And the OpenGL type is a GLU int, GL enum, and GL bit field. So multiple data types for the OpenGL types. I don't quite understand why that is or how that works, but that's what it says in the book, so I'll just roll with it. Gotta just roll with it. All right. Note, implementations of OpenGL have leeway in selecting which C data types to use to represent OpenGL data types. If you resolutely use the OpenGL defined data types throughout your application, you will avoid mismatched types when porting your code between different implementations. Good to know, good to know. All right, OpenGL's rendering pipeline. OpenGL implements what's commonly called a rendering pipeline, which is a sequence of processing stages for converting the data your application provides to OpenGL into a final rendering image. Figure 1.2 shows the OpenGL pipeline associated with version 4.5. The OpenGL pipeline has evolved considerably since its introduction. Okay, you guys can't see this, but let me see if I can bring up something here. We'll go and put up, let's see, OpenGL rendering pipeline. See if I can find the image that it's showing you in the book, or that it's showing us in the book, or at least a similar image. Okay. OpenGL Programming Guide. I'm actually going to type in the name of the book here. OpenGL Programming Guide. Okay. Okay, so this right here, this is the image that it's showing up that it has in the book for the OpenGL's rendering pipeline. So you see here, we start out with the vertex shader here, or vertex data here, and that feeds into the vertex shader. And then that feeds into the tessellation control shader. And the tessellation control shader feeds into the tessellation evaluation shader, which in turn feeds into the geometry shader, and then the geometry shader feeds into the primitive setup, which feeds into the clipping, which feeds into rasterization, which feeds into the fragment shader, and then that displays our two triangles, or the two polygons, as we like to call them. So that's what we're trying to get to, is rendering two polygons or two triangles on the screen. So, yeah, once we're finished with this, we're gonna have two triangles rendering on the screen. Okay. Okay, figure 1.2. Okay, yeah, this is called figure 1.2 in the book. And it is the OpenGL pipeline. Okay, OpenGL begins with the geometric data you provide, vertices and geometric primitives, and first processes it through a sequence of shader stages, vertex shading, tessellation shading, which itself can use 2 shaders, and finally geometry shading before it's passed to the rasterizer. The rasterizer will generate fragments for any primitive that's inside the clipping region and execute a fragment shader for each of the generated fragments. As you can see, the shaders play an essential role in creating OpenGL applications. You have complete control over which shader stages are used and what each of them do. Not all stages are required. In fact, only vertex shaders and fragment shaders must be included. Tessellation and geometry shaders are optional. Oh, interesting. So these two right here, these 2 shaders are optional. So only vertex shaders and the tessellation control right. Okay, so this red one, this one is required, and then fragment shaders are also required. Okay, and maybe that's why they're in red, is because they're required. Okay, that makes sense. So yeah, these 2 red ones are required, and these purple ones are optional. Okay. Now we dive deeper into each stage to provide you with a bit more background. We understand that this may be somewhat overwhelming at this point. Oh wow, there's a typo here in the book. Okay, they had the letter A there where they shouldn't be. Okay, so we understand that this may be somewhat overwhelming at this point, but bear with us. Hey, whoever, if the people who wrote the OpenGL programming guide, there is a typo in the 9th edition on page 11. Just so you guys know. If you're watching this, there is a typo on page 11 of the 9th edition of the OpenGL programming guide. We got the letter A where it doesn't belong. I don't know if this has been fixed in like the 10th edition, but I don't know. It's in the 9th edition. All right, moving on. Okay, preparing to send data to OpenGL. OpenGL requires that all data be stored in buffer objects, which are just chunks of memory managed by OpenGL. Populating these buffers with data can occur in numerous ways, but one of the most common is to specify the data at the time Populating these buffers with data can occur in numerous ways, but one of the most common is to specify the data at the same time as you specify the buffer's size using the GL named buffer storage command, like in example 1.1. There is some additional setup required with buffers, which we'll cover in Chapter 3. Okay, let me see if I can find that. Okay, so GL named buffer storage. That was in here somewhere. Ah, yeah, here we go, right here. Should be line 34 if you copy the code exactly. Or if you copy the code exactly like I've got it here, the GL name buffer storage should be in line 44. But you know, yours might be on a slightly different line because you're probably not following the code exactly like I wrote it, which is understandable. That's fine. There's flexibility here. But if it's not on line 34, it'll be somewhere close to line 34, I'm assuming. Unless you did something crazy with your version of the code. All right, next, sending data to OpenGL. After we've initialized our buffers, we can request geometric primitives be rendered by calling one of OpenGL's drawing commands, such as glDrawArrays, as we did in example 1.1. Okay, where was the GL draw arrays? That was... Ah, yes, here we go. Yes, GL draw arrays. And that should be on line 60 or close to line 60. All right. Drawing in OpenGL usually means transferring vertex data to the OpenGL server. Think of a vertex as a bundle of data values that are processed together. While the data in the bundle can be anything you'd like it to be, i.e., you define all the data that makes up a vertex, it almost always includes position data. Any other data will be values you'll need to determine with the pixel's final color. Drawing commands are covered in detail in Chapter 3, Drawing with OpenGL. Vertex shading. For each vertex that is issued by a drawing command, a vertex shader will be called to process the data associated with that vertex. Depending on whether any of the pre-rasterization shaders are active, vertex shaders may be very simple, perhaps just copying data to pass it through this shading stage, what we call a pass-through shader, to a very complex shader that's performing many computations to potentially compute the vertex's screen position, usually using transformation matrices described in Chapter 5. Okay. The sentence continues. Determining the vertex's color using lighting computations described in Chapter 7, or any multitude of other techniques. Okay, I'm going to read that sentence again because I kind of ended it prematurely. Okay. Depending on whether any other pre-rasterization shaders are active, vertex shaders may be very simple, perhaps just copying data to pass it through this shading stage, what we call a pass-through shader, to a very complex shader that's performing many computations to potentially compute the vertex's screen position, usually using transform matrices described in Chapter 5. Determining the vertex's color using lighting computations described in Chapter 7, or any multitude of other techniques. Okay, that's the full sentence there. Wow, what a sentence. Okay. Typically, an application of any complexity will have multiple vertex shaders, but only one can be active at any one time. Tessellation shading. After the vertex shader has processed each vertex's associated data, the tessellation shader stage will continue processing that data if it's been activated. As we'll see in Chapter 9, tessellation uses patches to describe an object's shape and allows relatively simple collections of patch geometry to be tessellated to increase the number of geometric primitives, providing better looking models. The tessellation shading stage can potentially use two shaders to manipulate the patch data and generate the final shape. Need some water here. Got to keep those vocal cords wet. All right, where were we? All right, geometry shading. The next shader stage, geometry shading, allows additional processing of individual geometric primitives, including creating new ones, before rasterization. This shading stage is optional but powerful, as we'll see in Chapter 10. Primitive assembly. The previous shading stages all operate on vertices, with the information about how those vertices are organized into geometric primitives being carried along internal to OpenGL. What? Hold on, let me read that again. The previous shading stages all operate on vertices, with the information about how those vertices are organized into geometric primitives being carried along internal to OpenGL. Does it mean carried along internal? Does that mean did they mean to say carried along internally? Because that would make more sense. I don't understand what they mean here where it says carried along internal. I'm assuming that's a typo and they meant to write internally and not just internal, but whatever. All right. The previous shading stage. Okay, let me see if it makes more sense if I replace internal with internally. Right. The previous shading stages all operate on vertices, with the information about how those vertices are organized into geometric primitives being carried along internally to OpenGL. Okay, yeah, now that makes more sense. Okay. Okay, I think I understand it. All right. Okay, next, the primitive assembly stage organizes the vertices into their associated geometric primitives in preparation for clipping and rasterization. All right. Clipping. Occasionally, vertices will be outside of the viewport, the region of the window where you're permitted to draw, and cause the primitive associated with that vertex to be modified so none of its pixels are outside of the viewport. This operation is called clipping and is handled automatically by OpenGL. So occasionally vertices are rendered outside of the viewport, and occasionally the vertices will be rendered outside of the viewport and cause the primitive associated with that vertex to be modified so none of its pixels are outside of the viewport. Okay, so basically, if you got a shape and part of the shape is outside of the viewport window, any part of the viewport window or any part of the shape that's outside of the viewport window is just going to be clipped off and won't be rendered. And OpenGL does that automatically. Hooray, automatic clipping. Okay. Rasterization. Immediately after clipping, the updated primitives are sent to the rasterizer for fragment generation. The job of the rasterizer is to determine which screen locations. I'm going to bring up this picture, bring the picture back. I'm going to put the picture right here. Right here. I'm going to put the picture right there in the code so you can look at the picture while reading the code. There we go. Okay. Okay, so yeah, we're on the clipping stage. I just realized I probably should have had this picture up while we were going over this because we just went through the primitive assembly. Okay, yeah, we're going through each of these stages now. So now we're talking about the rasterization stage here. So immediately after clipping, the updated primitives are sent to the rasterizer for fragment generation. The job of the rasterizer is to determine which screen locations are covered by a particular piece of geometry, point, line, or triangle. Knowing those locations, along with the input vertex data, the rasterizer linearly interpolates the data values for each varying variable. Varying variable. Sounds kind of redundant, but that's what it's got written there. Okay, for each varying variable in the fragment shader, and sends those variables as inputs into your fragment shader. Okay, I'm going to read that again. Knowing those locations, along with the input vertex data, the rasterizer linearly interpolates the data values for each varying variable in the fragment shader and sends those values as inputs into your fragment shader. Consider a fragment a candidate pixel in that pixels have a home in the frame buffer, while a fragment still can be rejected and never update its associated pixel location. Processing of fragments occurs in the next two stages. fragment shading, and per fragment operations. Note: how an OpenGL implementation rasterizes and interpolates values is platform dependent. You should not expect that different platforms will interpolate values identically. Okay, so basically, if you're doing this on Windows or Mac or Linux, it's going to be different on each of those three systems. So the way that Mac computer does it will be different from the way that a Windows computer does it, which will be different from the way that a Linux computer does it. So keep that in mind. While rasterization starts a fragment's life, and the computations done in the fragment shader are essential in computing the fragment's final color, it's by no means all the processing that can be applied to a fragment. I'll read that again. Okay, hold on, I need some water. Okay. While rasterization starts a fragment's life, and the computations done in the fragment shader are essential in computing the fragment's final color, it's by no means all the processing that can be applied to a fragment. You know, it says it's here, which is grammatically correct, but I think I would personally prefer to have it say it is here rather than it's. Even though the contraction is grammatically correct, I feel like it would flow better if we did not contract it is into its. So I'm going to read that again the way I want it to be written. Okay. While rasterization starts a fragment's life, and the computations done in the fragment's shader are in the fragment shader. Hold on. No. Wait. Hold on. Okay, start over. Okay. While rasterization starts a fragment's life, and the computations done in the fragment shader are essential in computing the fragment's final color, it is by no means all the processing that can be applied to a fragment. Okay, I think I understand that sentence. Okay. Okay, fragment shading. Okay, that was all still in the rasterization stage. Now we're moving on to the fragment shader stage. Fragment shading, the final stage where you have programmable control over the color of a screen location, is fragment shading. In this shader stage, you use a shader to determine the fragment's final color, although the next stage, per fragment operations, can modify the color one last time, and potentially its depth value. Okay, I'm going to read that again. The final stage, where you have a programmable control over the color of a screen location, is fragment shading. In this shader stage, you use a shader to determine the fragment's final color, although the next stage, per fragment operations, can modify the color one last time and potentially its depth value. Okay. The final stage where you have programmable control over the color of a screen location is called fragment shading. I want them to have the word called there. They omit the word called, and I guess it's grammatically correct without it. I personally would prefer to include the word called. Whatever. Okay. The final stage where you have programmable control over the color of a screen location is called fragment shading. In this shader stage, you use a shader to determine the fragment's final color and potentially its depth value. Fragment shaders are very powerful as they often employ texture mapping to augment the colors provided by the vertex processing stages. A fragment shader may also terminate processing a fragment if it determines the fragment shouldn't be drawn. This process is called fragment discard. A helpful way of thinking about the difference between shaders that deal with vertices and fragment shaders is this. Vertex shading, including tessellation and geometry shading, determines where on the screen a primitive is, while fragment shading uses that information to determine what color that fragment will be. Okay, I'm going to read that again. A helpful way of thinking about the difference between shaders that deal with vertices and fragment shaders is this. Vertex shading determines where on the screen a primitive is, while fragment shading uses that information to determine what color that fragment will be. Okay. Okay, so vertex shading determines location, and fragment shading determines color. Got it. Vertex shading equals color, fragment shading equal... No, wait. Vertex shading equals position, and fragment shading equals color. Why didn't they just say that? Okay. I'm going to pull up our... Go write a little note here. Go write a little note. Let's see. Solution Explorer. I'm going to add a markdown file. New item. Notes.md for markdown. And this is a markdown file. Is not code that will be compiled. It's more like notes and stuff. So we got. I'm going to change. Oh, we can change the size here. So vertex shading equals position, and fragment shading equals color. All right, that does help clarify. Oh, welcome to the stream, Connor Bugs. I see this is your first time here. I am Mephistus, your friendly neighborhood cyberpunk hacker trans girl, here to hack the system and infiltrate the network. Watch out for my evil twin, and welcome to the Agora network. Currently, I am doing a stream where I'm programming or going through a programming tutorial for OpenGL in C++. I am currently reading from a textbook called the OpenGL Programming Guide, 9th edition, by John Kesinich, Graham Sellers, and Dave Schreiner. Oh, they left the stream. So sad. Maybe they found graphics programming to be boring. Oh well. Where was I? Okay. Where was it? Okay, so a helpful way of thinking about the difference between shaders that deal with vertices and fragment shaders is this. Vertex shading determines where on the screen a primitive is, while fragment shading uses that information to determine what color that fragment will be. Okay. Okay, that makes sense. Okay, next, per fragment operations. Let's see. Do we have any? We have this additional fragment processing outside of what you can currently do in a fragment shader is the final processing of individual fragments. During this stage, a fragment's visibility is determined using depth testing, also commonly known as Z-buffering, and stencil testing. Oh, Z-buffering. Had so many issues with Z-buffering when I was trying to reverse engineer stuff in Final Fantasy XI. So many Z bufferings. I don't know if you guys ever played Final Fantasy 11, but they use Z buffering as a sort of trick to layer geometry on top of other geometry in order to give additional texture layers to certain pieces of geometry. Because the PlayStation 2 apparently, with the way it worked, you couldn't have more than one texture per object. And so when Squaresoft wanted to create geometry that had multiple layers on a texture, they had to create multiple layers of geometry, each with a separate texture, and then use Z buffering in order to make the different pieces of geometry blend together. It's quite an interesting way of doing it. Modern game engines do not do that because modern game engines can apply multiple textures to a single piece of geometry. So we're not bound by the limitations of the PlayStation 2 hardware anymore. But if you're doing reverse engineering for Final Fantasy XI, like I do, you kind of need to know that. All right, where was I? Okay, per fragment operations. Additional fragment processing outside of what you can currently do in a fragment shader is the final processing of individual fragments. During this stage, a fragment's visibility is determined using depth testing, also commonly known as Z-buffering, and stencil testing. During this stage, a fragment's visibility is determined using depth testing and stencil testing. Hold it. So, depth testing. I'll do testing or Z buffering and stencil testing. So depth testing and Z buffering are two names for the same thing. And then stencil testing is a different thing. Got it. So, okay. If a fragment successfully makes it through all of the enabled tests, it may be written directly to the frame buffer, updating the color and possibly depth value. Updating the color and possibly depth value of its pixel, or if blending is enabled, the fragment's color will be combined with the pixel's current color to generate a new color that is written into the frame buffer. Okay, hold on. I'll see if I can. Okay. If a fragment successfully makes it through all of the enabled tests, it may be written directly to the frame buffer, updating the color and possibly depth value of its pixel, or if blending is enabled, the fragment's color will be combined with the pixel's current color to generate a new color that is written into the frame buffer. Okay, I think I'm following that. I'll have to go through this a second time. Okay. As you saw in figure 1.2, there is also a path for pixel data. Generally, pixel data comes from an image file, although it may also be created by rendering using OpenGL. As you saw in figure 1.2, there's also a path for pixel data. Generally, pixel data comes from an image file, although it may also be created by rendering using OpenGL. Pixel data is usually stored in a texture map for use with texture mapping, which allows any texture stage to look up data values from one or more texture maps. Texture mapping is covered in depth in Chapter 6. With that brief introduction to the OpenGL pipeline, we'll dissect example 1.1 and map the operations back to the rendering pipeline. Okay, you know what? I'm going actually. I think I'm going to write out some notes here again. I'm going to go through that. Let's see. Okay, so we got our stages here. OpenGL's rendering pipeline. So one. Vertex data. Then 2. Vertex shader. What the thing is stupid. Why is it doing that? And tessellation. Tessellation has 2 L's. Tessellation control shader. Tessellation evaluation shader. Why is it not updating the numbers correctly? Oh well. What? Yeah. What is it, Bandito? Yeah. 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 Oh, Bandito wants something. What do you want? Yeah, you just want attention? Yeah. Yeah. You're a cute kitty. Okay, where was I? Okay, tessellation evaluation shader, and then geometry shader. And then we got to the primitive setup. And that goes into culling and clipping. And rasterization. I'm going to put this over here so we can see. There we go. Rasterization. And then fragment shader. Okay, and so yeah, for step 10, it doesn't actually have anything written there. It just shows the picture of the 2 triangles being rendered. So I guess I'll just write our triangles are rendered. Okay. And then, oh wait, oh, I see, I can, we want to do this. Look at this. Makes it all nice and colorful. I did not know about that. I haven't written a whole lot of markdown documents. So we got vertex data. Pairing to send data to OpenGL. Sending data to OpenGL. Then we got vertex shading. Then on this one we got for the tessellation control shader. I guess, you know what? We don't need subcategories for those ones. Where was that? Going on, let's see. Vertex shading equals position, fragment shading equals color. I'm going to change this to shading instead of. Okay, let's see. Fragment shading clipping. Okay, yeah, and then let's see which ones were required. Let's see. There we go. Okay, so this one required I'll put that in brackets. I'm going to change that to aim. And this one, gonna make these align. Make them align. Okay. This is not actual code, by the way. This is just note taking so we understand what the code is supposed to say. Okay. Oops. I accidentally opened Photoshop again. Hold on. Okay, so in these, looks like these things, these are different. I'm putting spaces between the parts of the pipeline that are conceptually different. Okay, so this would be color. Wait, no. This one was position, and this one was color. There we go. That's right. Because remember what it said there. Vertex shading is position, fragment shading is color. Okay, I think that makes sense. Oh, hello, Cat B Clock. Welcome to the stream. Oh, thank you for the raid. I don't know if your viewers will enjoy computer programming. Hi, person. How are you? Oh, hello, welcome. Thank you for the raid. Tarsus. Am I saying that right? Tarsus? Tarsit? Or is it Tarsrs? I don't know. Yeah, I'm doing learning. I'm learning how to program or OpenGL in C++. Thank you guys for the raid. Anyway, I'm reading through a textbook. As the textbook that I'm reading through as I learn OpenGL, it's called OpenGL Programming Guide, 9th edition, by John Kesenich, Graham Sellers, and Dave Schreiner. We've been doing programming with Python, also other things with planning for my future. Okay, cool. Yeah, I'm just doing. Yeah, I'm still a beginner with this graphics programming stuff. Nice, sounds interesting. Yeah, I've been studying. I've been learning computer programming for a while now, off and on. Probably not as consistently as I should have. It's like there'd be like some years where I'd study programming for a few months out of the year, and then there would be like years go by and I didn't study programming at all, and then I pick it back up again, learn some more programming, try to brush up on what I kind of forgot. It's probably not a good way to do it. I do not recommend doing it that way. Yeah, I probably would have been a much better programmer right now if I had been more consistent about how much I studied. Yeah, sporadic studying leads to subpar results. Learn from my mistake. Do not study sporadically, study consistently. I kind of fucked up on that in my life, but I am fixing it now. And I recommend that anyone else who is learning programming does not study sporadically like I did, and instead study consistently, because consistency is what leads to success. But of course, you all knew that, right? Yes, of course you knew it. Yeah, live and learn, continue, right? Right, okay, where were we? Okay. Anyway, let's see, we're just going over the different stages of the rendering pipeline for OpenGL. Let's see, where was I in the book? Okay, peripheral admin shaders. Okay, I got to this part. Our first program, a detailed discussion. Let's have a more detailed look at our first program, entering main. So yeah, I got this. This here is the program. I'm getting some underlined, getting some error text here. But yeah, this is the program copied exactly out of the book, exactly as it's written in the book. I just copied directly from the book here. So I did not write this. This is all from the book, copied exactly how it was there. Well, almost exactly. But I try to be as consistent as possible. Quite hard to do so with the time I have, but I like making random things. Yep. That's we all got time limitations we got to work around. All right. Let's have a more detailed look at our first program, entering main. Okay, here's our main function here. Let's see, can I get it? Yeah. Can I get the whole main function on screen at once? Yes, I can. Okay, that is our main function. Okay, there we go, main. That is the entire main function. Still got, there's some libraries that are not hooked up yet, which is why I'm getting the red underline errors. But we'll fix that in a little bit. Okay, entering main. Starting at the beginning of our program's execution. Cool, sometimes I forget books are very useful, yeah. Starting at the beginning of our program's execution, we first look at what's going on in main. The first 6 lines use glfw to configure and open a window for us. While the details of each of those routines is covered in Appendix A, we discuss the flow of the commands here. Okay. So yeah, the first 6 lines. So yeah, that would be this line, that one, 1, 2, 3, 4, 5. I guess when he says the first 6 lines, he means those ones. So yeah, we've got the, we declare main, and then we have glfw init, which initializes our window. And then we declare a window variable, which we just call window, and it is of the data type glfw window, and we assign that GFL using the command glfw create window. We pass in these 5 parameters, which is the height x and the height and width of the window, the name of the window, and then 2 other parameters which we're just leaving empty for now. Okay, the first function, glfw init, initializes the glfw library. So that's this function right here on line 66 in my code. And okay, this command processes the command line arguments provided to the program and removes any that control how glfw might operate, such as specifying the size of the window. glfw init needs to be the first glfw function that your application calls, as it sets up data structures required by subsequent glfw routines. glfw create window. Let's see, where's that one? Oh yeah, here, right. It's talking about this one right here. Okay. GLFW create window configures the type of window we want to use with our application and the size of the window as you might expect. While we don't do it here, you can also query the size of the display device to dynamically size the window relative to your computer screen. So yes, you see we've just got the X and Y values just hard-coded right in there, so it just sets the window. We just hard code the size of the window right there rather than doing it dynamically. Okay. GLFW create window also creates an OpenGL context that is associated with that window. To begin using the context, we must make it current, which means that OpenGL commands are directed towards that context. A single application can use multiple contexts and multiple windows, and the current context is the one that processes the commands you make. There's actually a current context for each thread in your application. Okay, so if you're doing multi-threading, you got to keep in mind that there's a context for each thread. Each thread has its own context if you're doing multi-threading. Keep that in mind. Okay, continuing on, the call to GL3W init, where is that one? Okay, right here. Okay, yeah, so this is what it was just talking about, GFLW make context current. Okay, so that takes the window we created and makes it into the current context. Oh, hello, Robin Hartz. Welcome to the stream. Hi, Mephistus. Yes, I'm doing some programming right now. If you watch on Twitch or YouTube, you can follow along with the code as I write it. I'm going through a textbook right now called OpenGL Programming Guide. It's frequently called the Red Book. I don't know if you're interested in computer programming, but I've got some people on Twitch who are watching me, and they seem like they're interested. I'm multi-streaming on multiple platforms right now, so if I address someone and you don't see them in chat, it's probably because they're in one of the other platforms that I'm streaming on. Just dropping in here before heading to bed. Okay, see you. Good. Thanks for stopping by, Robin Hartz. Anyway, let's see, where was I? Okay, let's see. Continuing on, the call to GL3W init. Ooh, okay, I'll catch you on Twitch. Okay. The call to GL3W init, that's this one right here. That initializes another helper library we use, GL3W. GL3W simplifies dealing with accessing functions and other interesting programming phenomena introduced by the various operating systems with OpenGL. Okay, I'm going to read that again. GL3W simplifies dealing with accessing functions and other interesting programming phenomena introduced by the various operating systems with OpenGL. Okay, I'm not quite sure I follow that, but we'll keep going. Without GL3W, a considerable amount of additional work is required to get an application going. At this point, we are truly set up to do interesting things with OpenGL. The init routine, which we'll discuss momentarily, initializes all of our relevant OpenGL data so we can use it for rendering later. The final function in main is a loop that works with the window and operating systems to process user input and other operations like that. Okay, so we've got a while loop here. So this is our while loop. Yeah, I'm mostly lurking. I just like hearing people talk. Okay, cool. Well, thank you for lurking, Tarsus. That helps with my viewership. Okay, where was I going? Okay. Okay, the final function in main is a loop that works with the window and operating systems to process user input and other operations like that. It's this loop that determines whether a window needs to be closed or not by calling glfw window should close, redraws its contents, and presents them to the user by calling glfw swap buffers, and checks for any incoming messages from the operating system by calling glfw poll events. Oh, okay. So So we got this line, redraws its contents. Okay, so this line, I'm going to add a comment here. Redraws contents and presents them to the user. And this one checks for incoming messages from the operating system. Okay, there we go. That so that clarifies these two functions right there. Okay, if we determine that our window has been closed and that our application should exit, we clean up the window by calling glfw destroy window and then shut down the glfw library by calling glfw terminate. Okay, so that's these two commands, these two right there. So this one, clean up the window, and this one, shut down the glfw library. So memory management. Got to do lots of memory management in C++. Okay, where was I? Okay, now what's next? OpenGL initialization. The next routine that we need to discuss is init from example 1.1. Once again, here's the code to refresh your memory, or I can just scroll up. Okay, so here's the initialization function. The initialization. Okay, I'll have to get this. Okay. I want to fit that whole function on screen. I'm gonna have to make the font smaller. Okay. Okay, initializing our vertex array objects. There's a lot going on in the functions and data of init. Starting at the top, we begin by allocating a vertex array object by calling GL create vertex arrays. Where is that at? Let's see, it's here. Let's see, it's GL create vertex arrays. Yeah, here we go. Yeah, they say at the top, but I guess they don't mean at the top of the function, but because that is, wait, no, that's gen or GL gen vertex arrays. I think that's different. No, okay, no, I'm wrong on that. That's not what they're talking about. Okay, yeah, I think they are talking about this part then. Okay, starting at the top, we begin by allocating a vertex array object by calling GL create vertex arrays. Oh, wait, no, they're talking about... Did I skip that part of the code when I was typing it in? Because I'm not seeing that in my code. Hold on, let me check back on that. I might have skipped that part of the code. Wait. GL create buffers, GL create named buffer storage, shader info. No, okay. Okay, now they're adding some stuff. Oh wait, I'm looking at the wrong function, that's why. Well, wait, no, I'm not. Oh, I see what they did there. They printed an extra line of code in the book that they have the code printed multiple times, and the second time they printed it, they added an extra line in here, and now they're discussing. Okay, that irritates me. Yeah, on the first pass of when they printed the code, it didn't have that line in there, and then on the second pass, it does have it in there. All right, well, there's the. Okay, so GL create vertex arrays. And it takes in two parameters, num VOA, or VAO, excuse me, VAOs, and then VAOs by itself. Okay, so that is our GL create vertex arrays function. Okay, so there's a lot going on in the functions and data of init. Starting at the top, we begin by allocating a vertex array object by calling GL create vertex arrays. This causes OpenGL to allocate some number of vertex array object names for our use. In our case, num VAOs, which are specified in the global variable section of the code. GL create vertex arrays returns that number of names to use in the array provided, VAOs in this case. Okay. This causes OpenGL to allocate some number of vertex array This causes OpenGL to allocate some number of vertex array object names for our use. In our case, num VAOs, which we specified in the global variable section of the code. And GL create vertex returns that number of names to us in the array provided. Okay. Okay, let's see. I think I understand what this is saying then. So this GL create vertex arrays causes OpenGL to allocate some number of vertex array object names. All right. Okay, so it has some number of vertex array object names for our use. In our case, num VOAs, which we specified. VAOs. I'm gonna put this up here. I'll put the note right here because that way we won't run out of horizontal space. GL create vertex arrays. causes OpenGL to allocate some number, num VAOs, of vertex array object names. Okay, and here's that VAOs was specified here as a global variable up here at the top. Mm-hmm. All right. Where was I? Okay, there it is. Vertex array object names. Some number. Okay. Causes OpenGL to allocate some number num VAOs of vertex array object names, VAOs. Okay. So this variable is the number of vertex array objects, and this is the actual vertex array objects. Okay. So my phone's not charging. Come on. There we go. Sorry, my phone wasn't charging. Gotta charge the phone. Okay, next, where are we? Okay. Some, in our case, num VAOs, which we specified in the global variable section of the code. GL create vertex arrays returns that number of names to us in the array provided. VAOs in this case. And okay. And returns to us in the array provided. Okay, so it's actually, this should actually go down here. That might be confusing. Okay, GL create vertex arrays causes OpenGL to allocate some number of VAOs of vertex object array names and returns that number of names to us in the array provided. Okay, so we're creating an array specifying the number of objects in the array and then assigning and then returning the names of the returning the array with the vertex array objects. OpenGL? Yes, OpenGL. Minishift. Have you ever done, welcome to the stream, Minishift. Have you ever done OpenGL programming? Because this is that's what I'm doing. I'm doing some OpenGL programming. I'm reading through a textbook right now called the OpenGL Programming Guide, 9th edition, by John Kesenich, Graham Sellers, and Dave Schreiner. It's often called the Red Book because it's got a red cover, and it's basically the industry standard for learning OpenGL. I'm 13 and I want to get into graphics programming. Where do I start? I guess start with the OpenGL programming book that I'm going through. Let me see. I'll pull up the thing. Yeah, this is the. I'll show you the book. OpenGL Programming Guide. Here we go. This is the book right here. This book. See this book? That's the book. You want to get into programming? This is the book, OpenGL Programming Guide. This is the book I'm currently reading through right now. I'm still in the first chapter, but I am learning this myself. I'm not paying $60 to learn OpenGL. Ask your parents to pay for it. Yeah, education is expensive. $60 is actually a pretty cheap price. College education is much more expensive than that, especially if you mess up. Don't ask me how I know that. Anyway, let's see. I guess if you don't want to pay money to learn OpenGL, I learned game development in C++ for free with YouTube. Well, I guess you learn OpenGL for free the same way then. Yeah, just keep coming back to my channel and we'll be going over it. Because I'm reading through this book. So if you don't want to pay money to read the book, I guess you could just follow my YouTube or follow my YouTube channel or my Twitch channel, and I'll just be going over it here. Should I go for OpenGL or Vulkan? I would say go for OpenGL first. OpenGL is easier. Vulkan is much more difficult than OpenGL. So there's basically three rendering libraries that are commonly used throughout the industry. There's OpenGL, which is the oldest and simplest of the three. Then there's DirectX, which was made by Microsoft and mostly for Windows. And then after DirectX is kind of a medium level difficulty. And then Vulkan is basically platform independent. And Vulkan is the hardest, most difficult version of graphics programming. So OpenGL, in order of difficulty, I would say OpenGL is easiest, DirectX is medium difficulty, and Vulkan is hard difficulty. So if you want to start with, you should probably start with the easy one, just because it's. Oh, welcome to the stream, Diligent Chipmunk. Welcome. Oh, they left the stream. Okay, never mind. Yeah, OpenGL is the easiest, DirectX is medium, and Vulkan is hard difficulty. But yeah, you'll, I would say, learn the basic concepts in OpenGL, and then later, once you've got a solid grasp of OpenGL, then you can move on to Vulkan or DirectX. So. I mean, you probably don't need to learn DirectX. You could probably just go straight from OpenGL to Vulkan. But I would definitely recommend learning OpenGL before Vulkan because it is easier and simpler, and there's so many different concepts that you need to learn and wrap your brain around that it'll be easier to start off using OpenGL first, and then once you've got that, once you have a solid understanding of OpenGL, then you can graduate to Vulkan. Okay, thanks for the advice. Bye. Okay, thank you. See you later, Minishift. I gotta go. I wish you both a good night. Stay safe, sleep well. Hope to see you another day. Okay, see you later, Tarsus. All right, where was I going? Where were you? Okay, so I'm on page 16 now in the book. We just went over. Okay, so we just went over this function here, GL create vertex arrays. Okay, here's a complete description of GL create vertex arrays. So void GL create vertex arrays takes in GL size IN and GL uint arrays. And it returns currently unused names for use as vertex array objects in the array arrays. Okay. The names returned are initialized with values representing the default state of the collection of uninitialized vertex arrays. It throws a GL invalid value if n is negative. Okay, so let's see. That's to go in the notes here. Let's see. This would probably be under preparing to send the data to OpenGL. So we got void GL create vertex arrays GL size I n and GL u int arrays. So that's the that's how the function works. That's the basic. That is the what do they call that? The description. I guess the stub, or I don't know. So, returns n currently unused names for use as vertex array objects in the arrays. I'm gonna add the word called there. Oh no. My Arium stream crashed. Hold on. Gotta boot up. Okay, so returns n currently unused names for use as vertex array objects in the array called arrays. And n is just short for number, so we could actually write out number there. I'm gonna make this complete, use a complete sentence here. So our void create vertex arrays returns a number of currently unused names for use as vertex array objects in the array called arrays. Okay. All right, what do we got next? Okay, we'll see numerous OpenGL commands of the form GL create for allocating names to the various types of OpenGL objects. A name is a little like a pointer type variable in C, in that you can allocate an object in memory and have the name reference it. Once you have the object, you can bind it to the OpenGL context in order to use it. For our example, we bind a vertex array object using GL bind vertex array. Okay, so GL bind vertex array. Where was that at? Ah, yes, here we go. GL bind vertex array. And takes in the VAOs. And so, and we've got a note here for that as well. So void GL bind vertex array. GL u int array. So GL bind vertex array does two things. When using the value array that is other than 0 and was returned from GL create vertex arrays, that vertex array object becomes active, which additionally affects the vertex array state stored in the object. When binding to an array value of 0, OpenGL stops using the previously bound vertex array. A GL invalid operation error is generated if array is not a value previously returned from GL create vertex arrays, or if it is a value that has been released by GL delete vertex arrays. Okay. Does two things. One, when when using the value array that is other than 0 and was returned from GL create vertex arrays, that vertex array object becomes active, which additionally affects the vertex array state stored in the object. When using the value array that is other than 0, and was returned from GL create vertex arrays, that vertex array object becomes active. Okay. 1. When using the value array that is other than 0 and was returned from GL create vertex arrays, that vertex array object becomes active. This affects the vertex array state stored in the object. And then 2. Oh, hello, welcome to the stream, Chocolate Cat Gameplay. Welcome. I'm doing some computer programming right now. I'm learning about graphics programming in OpenGL and C++. I don't know if you've ever done any programming, Chocolate Cat, but I'm doing some programming right now, going through a textbook, learning how to render graphics in OpenGL. a GL invalid. I'm writing down notes from the textbook. Helps me understand the code better. A GL invalid operation error is... Hi, Math. Yes, hello, Chocolate Cat. Welcome. A GL invalid operation error is generated if array is not a value previously returned from, I'll just call from GL. From GL create vertex arrays. Or if it is a value that has been released by GL delete vertex arrays. Okay. So the void GL bind vertex array does two things. When using the value array, that's this here, and that is other than 0. So as long as this value is not 0, and it was returned, that was returned from the from this function up here, create vertex arrays, then that vertex array object becomes active, and that affects the vertex array state stored in the object. Second thing it does is a GL invalid operation error is generated if array is not a value previously returned from the GL create vertex arrays function up here, or if it is a value that has been released by the GL delete vertex arrays. Yeah, I don't know if this might be kind of boring if you're not into programming. But yeah, I'm trying to learn this stuff myself, and I figure, you know what? I may as well stream it while I'm learning it, you know? Okay. That way I can also pass the knowledge on to anyone else who watches my stream. We will learn together. Okay. In our example, after we create a vertex array object, we bind it with our call to GL bind vertex array. Object binding like this is a very common operation in OpenGL, but it may not be immediately intuitive how or why it works. Let's go back over to the code. So you've got this up. It's talking about this line of code right here, GL bind vertex array. Where was I? And let's see. Okay, object binding like this is a very common operation in OpenGL, but it may not be immediately intuitive how or why it works. When you bind an object, e.g. when GL bind is called for a particular object name, OpenGL will make that object current, which means that any operations relevant to the bound object, like the vertex array object we are working with, will affect its state from that point on in the program's execution. After the first call to any GL create command, let's see, hold on. Gotta turn the page here. All right, okay. After the first call to any GL create function, the newly created object will be initialized to its default state and will usually require some additional initialization to make it useful. Think of binding an object like setting a track. Okay, think of binding an object like setting a track switch on a railroad yard. Once a track switch has been set, all trains go down that set of tracks. When the switch is set to another track, all trains will then travel that new track. It is the same for OpenGL objects. Generally speaking, you will bind an object in two situations. Initially, when you create and initialize the data it will hold, then every time you want to use it, and it's not currently bound. Okay, let me read that again. Generally speaking, you will bind an object in two situations. Initially, when you create and initialize the data it will hold, then every time you want to use it and it's not currently bound. Okay. Oh, welcome to the stream, Liquid Squid. He joined the stream for the first time and then left. I guess I missed. I didn't see him. I didn't greet him. Oh well. I guess that's what happens. People join the stream, and then if you don't greet them right away, they leave. Okay. Then every time, and it's okay. You will create and initialize the data, then every time. Generally speaking, you will bind an object in two situations. Initially, when you create and initialize the data it will hold, then every time you want to use it and it's not currently bound. We'll see this situation when we discuss the display routine where GL bind vertex array is called the second time in the program. Oh yeah, so we're in the initialization routine right now. And that this is the first place we call the GL bind vertex array function. And then it is also called again right here in the display routine. That's what they're talking about. So GL bind vertex array is called a second time here in the display routine. And this is the first time it is called in the initialization routine. I was leaning away from the microphone. Hope you guys could still hear me. Okay. Because our example is as minimal as possible, we don't do some operations that you might in larger programs. For example, once you're finished with a vertex array object, you can delete it by calling GL delete vertex arrays. So we've got a draw array. We don't have a GL delete vertex array. Probably would be good to have that though. You know, I'm going to add that command anyway, just because I want to do it. GL delete vertex arrays. Okay. Oop, come on. Clean up the vertex arrays. What is this? Int main argc okay. Okay, now we got to go back over to the, I'm going to copy this part right here, go back into our notes. GL delete vertex arrays. And so it takes in the parameters GL size I, n, or number. Yeah. I'm going to change this back to okay, so let's see. Okay, GL size I n, and then const GLU int arrays. And that, okay. So this one deletes the end vertex arrays objects specified in arrays, enabling the names for reuse as vertex arrays later. If a bound vertex array is deleted, the bindings for that vertex array become 0, as if you had called GL bind vertex array with a value of 0, and there is no longer a current vertex array. Unused names in arrays are released, but no changes to the vertex array state are made. Not sure I understood that. And so maybe if I write it down, if I type it in, that helps me understand it. Deletes the number n of vertex arrays objects specified in arrays. This deletes the number of n, deletes the number n of vertex arrays objects specified in arrays. Names can be reused as vertex arrays later. Okay, deletes the number and of vertex arrays objects specified in arrays. The arrays variable there those names can be reused as vertex arrays later. I'm going to this frees up those names. Okay, deletes the number and of vertex arrays objects specified in arrays. This frees up those names to be reused as vertex arrays later. So, if a bound vertex array is deleted, the bindings for that vertex array become 0. If a bound vertex array is deleted, the bindings for that vertex array become 0. All right. Okay, so if a bound vertex array is deleted, the bindings for that vertex array become 0, as if you had called GL bind vertex array with a value of 0. And there is no longer a current vertex array. Okay, if a bound vertex array is deleted, the bindings for that vertex array become 0, and there is no longer a current vertex array. Okay. If a bound vertex array is deleted, the bindings for that vertex array become 0, and there is no longer a vertex array. Got it. Okay. There is no longer a current vertex array. If a bound vertex array is deleted, the bindings for that vertex array become 0, and there is no longer a current vertex array. Then unused names in arrays are released, but no changes to the current vertex array state are made. Unused names in arrays are released, but no changes to the current vertex array state are made. So, unused names in arrays are released, but no changes to the current vertex array state are made. But there are no changes made to the current vertex array state. Kind of typing out what it says in the book and then trying to reword it in my own way helps me understand it a little better. See, unused names in arrays are released, but there are no changes made to the current vertex array state. Oh, hello, welcome to the stream, Carter Water and Surrounded by Perverts. Oh, thank you for sharing the stream, Surrounded by Perverts. Thank you, welcome, welcome. I'm just doing some computer programming right now. I'm learning OpenGL graphics programming using C++. I don't know if you've ever done graphics programming before. I should be here more often. Oh, yes. Oh, thank you for... Sorry. Oh, it's fine. It's fine. I don't stream enough and during times when other people are watching. So, yeah, lately I've also been kind of... I don't know. I haven't been keeping up with my or schedule, or rather keeping a schedule at all. I've kind of been just streaming whenever, never following a schedule. And even if I make a schedule, sometimes I don't follow it. And I guess that has made it very difficult for people to tune into my streams because they never know when they're going to happen. But I'll try to get better about doing that, about streaming at more often and at more consistent times, so that it's easier for people to watch my streams. Because I notice I haven't been getting a whole lot of viewers. And I think a big part of that is not streaming enough and not streaming at consistent times. So I'll try to fix that. So don't blame yourself. Anyway, I'm currently triple streaming on Irium, Twitch, and YouTube simultaneously. So if you want to go over to Twitch or YouTube, you can watch my stream there. And you can also follow along with the code as I'm writing it. I'm copying out of a textbook. It's not original code, but I'm learning. And if you want to follow along, you can watch me on Twitch or YouTube. Or if you just want to chill on Irium, you can listen to me talk about the code. Probably be harder to understand if you just listen on Irium, but that's okay. I need a little bit of background music. You need to go to YouTube and get some background music going here. What is this? Rest in peace, Ryan Karazija. Oh yeah, that musician who did Low Roar, he's passed away. Sad. Okay, let's see. We're just going to do some of this. I think this is AI music, but whatever. Okay, where were we? Okay, yeah, we were going over the GL delete vertex arrays function. So deletes the number and deletes the end vertex arrays objects specified in arrays. Okay, so GL delete vertex arrays deletes the number n of vertex arrays. Okay. Finally, for completeness, you can determine whether a name has already been created as a vertex array object by calling it GL is vertex array. I'll turn down that music. A little loud there. Okay, fine. Finally, for completeness, you can also determine whether a name has already been created as a vertex array object by calling it GL is vertex array. Do they use that function here? I don't think they use that function here. I don't see it anywhere in the code. I don't remember typing that. Oh, we'll type it here. GL is vertex array. So you can see it's GL for graphics library is vertex array. And it takes in a GL uint array. So I guess that's an what was the GL uint? Oh, that was. I will not worry about that right now. Where are we? Okay, we're on the. Okay. Okay, GL. I don't know if I want to type out this. It's got a bunch of different ones here, and I don't know if I want to type out all of them, but I'll type out at least the function header. So GL is vertex array, returns GL true if array is the name of a vertex array object that was previously created with GL create vertex arrays but not subsequently deleted. Returns GL false if array is 0 or a non-zero value that is not the name of a vertex array object. Okay, you'll find many similar routines of the form GL delete and GL is for all the different types of objects in OpenGL. Okay. Returns GL true if array the name of a vertex array object that was previously created but not subsequently. Oh, hello! Welcome to the stream name. I see it's your first time here. I am Hephaestus, your friendly neighborhood cyberpunk hacker trans girl, here to hack the system and infiltrate the network. Watch out for my evil twin, and welcome to the Agora network. Ah, is that a femboy? Oh? Yes? No? Maybe? I don't know. What? Oh? What? What's O? Q? Q? You got faces there. He was disappointed. Are you disappointed? Oh well. You can stay here. I'm doing some computer programming right now. I thought you were a fanboy. I guess I'm kind of in that, kind of yes and no. I guess like right now I'm like very early in transition, and I'm kind of in a stage where I'm still kind of a fanboy, so yeah. Oh, you crying? You're crying about that? Why? Why you cry about that? Well, I mean, if you looked at me in real life, I'd probably look like more of a fanboy and rather than a trans girl, but you know, whatever. Do you like femboys? The revolution will not be televised. Boondocks. Yeah. Yeah, I will. I roast. I will do anything people want. Well, I mean, I'm still kind of. I mean, there's a very thin line between trans girls and femboys, you know. Anyway, I'm doing some computer programming right now. I'm learning about OpenGL graphics programming. Some kids say that it's gay. I mean, that depends on what you mean by gay. There's a lot of things that are gay. But don't worry about what the kids say. You just worry about what you like. Anyway. Yeah, I'm doing some graphics programming. Currently triple streaming on Arium, Twitch, and YouTube. And if you want to follow along with the code as I write it, I'm copying out of a textbook. But if you want to follow along, you can watch my stream on Twitch or YouTube. And that should help with if you're interested in learning graphics programming. Anyway, I was saying, I'm going over this function here. GL is vertex array, and it's not subsequently deleted. Okay, so the GL is vertex array takes in a GL uint variable. In this case, we called it array, and returns GL true if array is the name of a vertex array object that was previously created but not subsequently deleted. Oh, thank you for the LOL name. Thank you, thank you. Did I spell subsequently correctly there? Okay. And, okay. Returns GL false if... Okay, returns GL false if array is the name of a vertex array object. If okay, returns GL false if array is okay, is 0 or a non-zero value that is not. Yeah, my little bro is calling. See you later. Okay, see you, name. Or a non-zero value that is not the name. Oh, hello, welcome to the stream, Chief Blackwood, pre-debut. I see this is your first time here. I am Hephaestus, your friendly neighborhood cyberpunk hacker trans girl, here to hack the system and infiltrate the network. Watch out for my evil twin, and welcome to the Agora Network. I see that you are a pre-debut. Welcome. Do you have a debut date set yet, or no? If you've got a debut date, I'll try to make it. Good thing I don't have cybernetics. Why is that a good thing? Okay. Not the name of a vertex object. Okay. No hacking? Why? Oh, I see. You can't get hacked. Oh, you're saying I can't hack you if you don't have any cybernetics. I get it. All right, anyway. Yep, okay. All right, do you have a debut date yet or not yet? Okay. GL is vertex array, GL uint array. Returns GL true if array is the name of a vertex array object that was previously created but not subsequently deleted. Returns GL false if array is 0 or if a non-zero value that is not the name of array, if array is 0, or if array, okay. Can't say under Bond Live and NDA. Oh, okay. I see. I didn't. Yeah. Is Bond Live fun? I haven't ever actually used the gone through Bond Live. Lots of Bondies on Irium. Oh, thank you for the follow, Chief Blackwood. Thank you. You know what? Since you follow me and you're a pre-debut, I'm going to follow you, and I'll try to make it to your stream if I can. As long as it doesn't overlap with my work schedule or my school schedule or the schedule of another streamer I want to watch, then I will try to make it to your debut if I can. We got 7 more yesterday. Oh, cool, nice. 7 more streamers, is that what you're saying? Anyway, so yes. Anyway, GL is vertex array, returns GL true if array is the name of a vertex array object that was previously created but not subsequently deleted. Returns GL false if array is 0 or if array is a non-zero value that is not the name of a vertex object. Okay. Sorry, I don't know how interested you are in computer programming, but I'm doing like a programming lesson where I'm also teaching myself in the process over on YouTube and Twitch, where I'm reading through a textbook and just implementing the code that it's from the textbook and trying to learn what it means as well. So seems like a lot of people from Bond Live are more singers or musicians, I guess. I don't know. Anyway, returns GL false if array is 0 or if array is a non-zero value that is not the name of a vertex object. Okay, I think I understand that function now. No, just 7 more that joined us. Okay. Okay, you'll find many similar routines of the form GL delete and GL is for all the different types of objects in OpenGL. Okay. So these GL is and GL delete are going to be reused throughout the GL library, the OpenGL library. Okay, where are we? Allocating buffer objects. A vertex array object holds various data related to a vertex array object holds various data related to a collection of vertices. Those data are stored in buffer objects and managed by the currently bound vertex array object. While there is only a single type of vertex array object, there are many types of objects, but not all of them specifically deal with vertex data. As mentioned previously, a buffer object is memory that the OpenGL server allocates and owns, and almost all data passed into OpenGL is done by storing the data in a buffer object. The sequence of initializing a buffer object is similar in flow to that of creating a vertex array object, with an added step to actually populate the buffer with data. Where was I? The sequence of initializing a buffer object is similar in flow to that of creating a vertex array object, with an added step to actually populate the buffer with data. Okay. To begin, you need to create some names for your vertex buffer objects. As you might expect, you'll call a function in the form glCreate, and in this case, glCreate buffers. In our example, we allocate numVBOs, short for vertex buffer objects, a term used to mean buffer object used to store vertex data, to our array buffers. Here is a full description of glCreate buffers. Okay, let's see. That was a sentence. Okay, in our example, we allocate numVBOs to our array buffers. Okay, in our example, we allocate the variable numVBOs to our array buffers. VBOs is short for vertex buffer objects, a term used to mean a buffer object used to store vertex data. Okay, so here we go. Like this one is gonna be sending object. I think we're in the part where we're sending data to OpenGL now. Allocating buffer objects. Oh, who just joined? Oh, welcome to the stream, Mr. Bones. I see this is your first time here. I am Hephaestus, your friendly neighborhood cyberpunk hacker trans girl, here to hack the system and infiltrate the network. Watch out for my evil twin, and welcome to the Agora Network. Today I am doing some computer programming in C++ and OpenGL. I'm reading from a textbook called the OpenGL Programming Guide, and I'm learning how to do graphics programming. I don't know if you've ever done any computer programming yourself, but it's something I'm trying to get into. All right, where was I anyway? Okay, the sequence of initializing a buffer object is similar in flow to that of creating a vertex array object with an added step to actually populate the buffer with data. To begin, you need to create some names for your vertex buffer objects. As you might expect, you'll call a function in the form of glcreate, in this case, glcreateBuffers. In our example, we allocate num VBOs. Okay, where is the example? Okay, num VBOs. Okay, this... Is that even in the code? I don't remember that. I don't remember seeing that in the code. In this, in turn, cares glcreateBuffers. Okay, maybe it was in the buffers. I'm not seeing it. Okay, glcreateBuffers. Where we got? Can you guys hear the music okay, or is it too quiet? I turned it down because I was having difficulty talking over it. Nope, I've not tried programming, but sounds like it could be cool to learn. Okay, cool. Yeah, I'm currently streaming on Twitch and YouTube as well. If you want to follow along and watch and see the code, you can also join my stream on Twitch or YouTube. And then you can follow along. So we've got our glcreateBuffers. Where is the... I'm not seeing... Where's the glcreateBuffers? Okay, here it is. glcreateBuffers. Yeah, here we go. glcreateBuffers, number buffers, and buffers. Okay, he's explaining it differently than it looks like it was written in the code. Maybe I'm just not understanding it. glcreateBuffers, num buffers, and then buffers. So yeah, exactly like I have it there on line 38. I'll copy this over here. GL size I n GL uint buffers. Okay, here we go. And this returns number n of currently unused names for buffer objects in the array buffers. Okay, so GL create buffers returns number n of currently unused names for buffer objects in the array called buffers. Okay, the names returned in buffers do not have to be a contiguous set of integers. Throws GL invalid value if n is negative. Throws GL invalid value if n is negative. Okay, and it says the names do not have to be contiguous. Okay, GL create buffers. GLU int. Oh, this is supposed to be GLU int. There we go. No, not unit. Uint. GLU int, which points to an array of buffers. Returns number n of currently unused names for buffer objects in the array called buffers. The names do not have to be contiguous. Do not have to be contiguous. Integers. The names do not have to be contiguous integers. Throws GL invalid value if n is negative. The names returned represent newly created buffer objects with default valid state. 0 is a reserved buffer object name and is never returned as a buffer object by GL create buffers. Oops. Oh no, I bent my page. So, names returned present newly created buffer objects with default valid state. Got 0. 0 is a reserved buffer object name and is never returned. Okay, 0 is a reserved buffer object name and therefore is never returned by this function. All right, once you have created your buffers, you can bind them to the OpenGL context by calling GL bind buffer. Because there are many different places where buffer objects can be in OpenGL. Okay. Because there are many different places where buffer objects can be in OpenGL, when we bind a buffer, we need to specify what we'd like to use it for. What? More typos here. Because there are many different places where buffer objects can be in OpenGL, when we bind a buffer, we need to specify which we'd like to use it for. Well, they say what we'd like to use it for, but that doesn't make sense, so I'm going to say which object we'd like to use it for, because that looks like another typo in the book. Okay, because there are many different places where buffer objects can be used in OpenGL, when we bind a buffer, we need to specify which object we'd like to use it for. Okay, that makes sense. In our example, because we're storing vertex data into the buffer, we use GL array buffer. The place where the buffer is bound is known as the binding target. There are many buffer binding targets which are each used for various features in OpenGL. There are many buffer binding targets which are each used for various features in OpenGL. We will discuss each target's operation in the relevant sections later in the book. Here is a full detail for GL bind buffer. Okay, so GL bind buffer, that's the next one we're going over. CGL, yes, here we go. GL bind buffer. Okay, I'm going to kind of skim over this because I want to kind of get to the end of the chapter. I don't want to write out full detailed notes for every single function it mentions because it's going through a lot of them. I might do that later still, but where was I? We just went over the GL create buffers. Okay, now we're on GL bind buffers. So GL bind buffer. GL enum target GL uint buffer. There we go. GL bind buffer, GL enum target, GL uint buffer. Okay, specifies the current active buffer object. Target must be set to one of these commands: GL array buffer, GL atomic counter buffer. Okay, buffer specifies the buffer object to be bound to. Specifies the current active buffer object as the specifies target as specifies the current active buffer object as the target. The buffer specifies variable parameter the object to be bound to. Okay. GL bind buffer, GL enum target, GL uint buffer. Okay. Okay, specifies the current active buffer object as the target. The buffer parameter specifies the object to be bound to. Okay, that makes sense. GL bind buffer does two things. First, when binding to a previously created buffer object, that buffer object becomes the active buffer object for the specified target. And second, when binding to a buffer value of 0, OpenGL stops using any buffer object previously bound to that target. Okay. So when binding to a previously created buffer object, that buffer object becomes the active buffer object. That buffer object becomes the active buffer object. For the specified target. And when binding to a buffer value of 0, OpenGL stops using any buffer previously bound to that target. Oh no! My Arium stream died. Oh, I see why. My phone wasn't plugged in. Oh. What am I watching on this chair? Okay, let's see. Okay, when binding to a buffer value of 0, OpenGL stops using any buffer object previously bound to that target. As with other objects, you can delete buffer objects with GL delete buffers. I'm going to copy out down all the headers for all the functions they're going over here. And we'll just do that. GL, see, what did we do? We just went over GL bind buffer. Now GL delete buffers. And then we've got GL Boolean GL Boolean GL is buffer. I'll go back over these in a second. We got void GL named buffer storage. We got void GL vertex attrib pointer. I think that might be yeah. It's my phone battery. Okay, the phone's back up. vertex shading position. Okay. I guess you gotta write down all these. Where was I at? Ooh. Vertex attribute pointer. Okay, then we've got void. GL enable vertex attrib array. GL disable vertex attrib array. Okay, there we go. Sorry, the stream ended on Virium there for a bit because my phone battery died because I didn't realize it wasn't plugged in. Void GL clear buffer fee. GL draw arrays. And then we've got GL enable, GL disable. GL Boolean, GL Boolean, GL is enabled. We'll go back through and fill those in. Okay. GL enum capability. I don't know what time is it. 1:49 a.m. Okay, probably gonna continue doing this for about 10 more minutes, and I'm gonna go to bed. And then I'll continue with chapter 2 tomorrow. Mode GL int first GL size I count. GL enum buffer GL int draw buffer const GL float GL disable vertex. So GL uint index. Okay, here we go. GL vertex attrib pointer. Okay, we got this. GL vertex attrib pointer. Okay, this one right here, that's the one. Oh, welcome to the stream for the first time, you gentle platypus. I see this is your first time here. I am Hephaestus, your friendly neighborhood cyberpunk hacker trans girl, here to hack the system and infiltrate the network. Watch out for my evil twin, and welcome to the Agora network. How are you doing? I'm doing some programming right now. You can follow along on Twitch or YouTube. But yeah, I'm learning some C++ with OpenGL. So we've got GL uint index GL uint size GL enum type GL boolean normalized GL size stride and then const GL void pointer. One, two, three, four. So GL size in const GL uint buffers. And this one, we got GL named buffer. Wait, no. GL is buffered. GL uint buffer. GL uint buffer. GL is buffer. GL uint buffer. Point GL named buffer storage. Okay, there's one. There's GL uint GL uint buffer GL size I pointer size const void data GL bit flags. Okay, and then we'll go over. I'm getting kind of tired. So those are all the other functions that are discussed. I'm getting tired. And so I'm gonna finish this tomorrow. All right. Wow, 4-hour stream.